Okay, for today, we meet again in the blockchain courses, and today's discussion is we'll discuss deeply on the blockchain architecture. So, from this session, I will invite you to discuss and learn on blockchain in the technological aspect, yeah, especially on the architecture first, and then later on we will discuss until the algorithm and also the how to develop the blockchains. Yeah. So what the purpose of this discussion is give you some knowledge and also understanding about the architecture of the blockchains, why blockchain is different from the common architecture that we already know, and then what the component and also how the work of the blockchains. Yeah. So hopefully after you understand about what is the blockchain architecture, you have the technological component that can support the work of the blockchains, and also why the blockchain need very specific technology and also processes that need to support the process of the blockchain itself. Yeah. So for the blockchain itself, actually, you already know about the characteristic that we already discussed in previous discussion. Yeah. So for for achieve and also to address the blockchain characteristic, so the architecture should be developed and also work with the specific criteria too. Yeah. So that's why the blockchain is like unique and also advanced technology that make the blockchain itself is can be work. Yeah. And in the blockchain architecture, you will see about the why the blockchain is also is very have some challenge here to implement in very in many industries. So why the blockchain is in other words is like difficult to implement in the industries, but actually it's not difficult, but we need to have some some new paradigm to implement the blockchains. So our discussion is we will try to discuss about the node yeah, itself that we call the P2P network. We call the peer-to-peer network. Yeah. So this is like the basic configuration of the network between node that involved in the blockchain node. And then we have the properties of the block and also the genesis of the blocks. Yeah, the genesis block. Yeah. So this is like the properties of block will be defined. Which one is the private blockchain, which one is the public blockchains. Yeah, and then how the transaction within the ledger that we already know that the ledger will be distributed and also will be placed in every node that involved in the blockchain processes. And then we also need the validation processes. Yeah, the validation processes is like close with the mining processes. Yeah, which is the mining process is very important because it will be give some some check point and also the validation point for every transaction, and then the transaction will be accepted and approved in the between the network. Yeah. And then also the consensus, yeah, the consensus within a blockchain architecture. This is like the unique point that blockchain is exists, yeah, which is consensus. And then proof of work. It's also very important to understand about how the blockchains can work. Yeah. So as architecture, you can see in here that the architecture itself is not only discussed in the network configuration level, yeah, but also on the process, the validation processes, and also the consensus give some point that we also work on the business process level. Yeah. So in this case, we can see in the configuration is very the structure and also the architecture is very important. And from here, from this point, we understand that the blockchain have the different architecture between the others. Yeah. So when we try to identify this point, you can see that the blockchain is work with the peer-to-peer network, for example. So if you still remember within the computer networks course, actually the P2P is very not old actually, but yeah, it's like very basic network access, yeah, and also in the very basic network architectures, yeah. It's bridging one or two network each others, and then they work directly into the network, yeah, point to point, yeah. So it's called point to point because every node is same in the same level, and then they can access the other node, and the other node can also access the another nodes, yeah. So that's why this P2P is very basic configuration on the network actually. But the most important of the P2P network is every node will be validate all the another node that work in the same network, yeah. So the trusty level in every node is very high, and then they depend all the validation across the network. So yeah, this is close with the like if you still remember with the private network, yeah. So we have like a network, and then we define the network as a private network, and then only work between the node that already registered in the one network. So that's why this is the basic of the the distributed node. But even distributed node, it's and the node itself is verified and also in one single network management, yeah. So this is the P2P network. And the property of block and kinesis of block actually is like is still remember about the data block, yeah, in the also in the computer network or and data communication course. You also understand that every traffic, every transaction is actually in the form of the data block, yeah. And then in the data block will be have some address that as destination of the data communication, and then the second is will be will be in the form of the data itself, and then another properties or attribute that need to be added in the data block, yeah. So in here that we also play with this one, but the difference is the block and the genesis block will be distributed to all the node that in the one P2P networks area, yeah. And then all the transaction will be logged, will be noted, and will be recorded into the ledgers, yeah. So we will all the ledger will be will be verify the transaction, and then will be have the information from all the transaction. And then the validation processes is like the process how to validate the transaction is legal, and then is uh, is is already finished by one the network that register into the P2P network. And then of course the process to do the transaction and then validate the transaction is based on the consensus that already defined before before in the first time, yeah. So and then it will be proof of works. uh, the nice one of the basic one of the network itself. So actually we know that we already have the two kind of the computer networks type, yeah. The first is centralized, yeah. Centralized is all the network will be connected into one hub or one switch or one point that register and auto manage all the network between the area. So if, actually all the transaction, all the traffic data will be came to the hub or the switch node, and then will be distributed to another node, yeah. So it's mean in other word is all the node will be connected one point to point to the switch or to the hub, yeah. And then they will communicate to another node via or using the hub, yeah. So that will be decentralized. All the transaction, all the log, and all the the registry, and then the all the things will be managed and in the centralized hub in here. Yeah. And it's different with the decentralized. Yeah, decentralized is we already have several hub actually. Yeah, and every hub will be connected each others in here, and then in every hub they will have a node here. So they manage several nodes, and then they connect it to another hub to bridging communication with the node in the others hub. Yeah. So you can hear actually it's basically it's also centralized, yeah, in one perspective, but every hub will be connected each other. So they have the space to communicate each others, and also they also have the opportunity to manage the node between them, yeah, in their area, yeah. So that will be the nice one. So in the blockchains, we have this architecture that we call the distributed ledgers. Yeah, the distributed ledger is more. It's like a mass network actually. Yeah, actually the heart is in the decentralized, but in the decentralized, every node have the capabilities and also have the features to communicate to every node. Yeah, so it's mean all the node it will be independent, and then they can communicate each other to any node that they want. Yeah, so in here you can see that we will have not only just decentralized or centralized network, but this is like a mesh network. Yeah, so the mesh network make everyone can see, and then can can verify all the transaction from other nodes, and it become a very very tight network here. So the difference between the centralized and decentralized is if it still depend on the hub, yeah, or the parent node that distribute and also manage the nodes. Yeah, but in here is every node is independent. So because they are independent, so they can define and also decide which one will be net, connected to other nodes. Yeah. So in the distributed ledgers architectures, we have a public node here. In here, the definition is user are anonymous here. So in here, all the network is maybe is only registered by the ID node, and then we doesn't need to know about who behind this node here. So it's been if I deploy the node in the laboratory and then connect it to the network of the blockchain network in the global or in the internet, they directly allow me to connect to the network, and then I become the one of the public node in here, and I still become the anonymous, yeah, in here. So yeah, this is the kind of like when we want to connect it to the internet, and we doesn't need to to register, or maybe sometime something like that to connect it to the network. Yeah, so it's mean we can have as much as we can the node that will be support the distributed ledger in here. And we also have another type of the distributed ledger. This is more private because all the users that involved in this mesh network will not be the anonymous anymore. Yeah, they will be registered. Then they will be have private network. Yeah, so we know who behind this node, and then this is also who become the in this node, and so on. So the who in here is like the IP address, for example, and then maybe they apply some identity to register as one of the distributed ledgers. Yeah. So in here, so we can see that actually it's same, yeah, mesh network, but they apply some some anonymity and also the unanonymity that we call the public and also the private private features on here. Yeah. So based on this, we can see that in the blockchain itself, we can see that the network can be in the form of the public network like this one, and then it's also can become like a private network. Yeah. So it is like a private network. It's mean like there's only user or registered user can join this network. Yeah. So this is like the the computer network topologies. So in the experience, for example, or maybe in experiments, yeah. So we can say like have a network, a computer network, for example, 1 or 5 node, and then we distribute all the node into the networks that, and then we configure a mesh network, yeah, between the node, and then we define in this 5 node will be anonymous, or maybe we need to have a private node on every network, yeah. So that's why it's a difference, yeah. And of course, when we can, if we analyze the network, a blockchain is like a chain of blocks, yeah, which contain specific information or databases, yeah, but in secure and genuine way that is grouped together in a network. Yeah, the network itself is peer-to-peer. So why this is called peer-to-peer? Because if we go back to the network configuration, we can see that actually all the nodes will be one-to-one connection. Yeah. Even they will connect it with to many net nodes here. So that's why many peer-to-peer network actually. Yeah. So it's different with this one. Yeah. So this is like they only have the opportunity to connect to one network, which is a hub. Yeah. So that's why it's different in here. In other words, blockchain is combination of computer linked to each other instead of a central server. Yeah, meaning that the whole network is decentralized. Yeah, so it's mean you can see in here, say like all is decentralized. Yeah, because all the node will be hub also, and in the same time they also become a node. Yeah. The work of blockchain actually we can compare to work done by the Google Docs facilities, yeah, or features. Yeah. You may recall the day of tossing over doc, okay, and document waiting for other participants to make necessary edits. Yeah. These days, with the help of Google Doc, it is possible to work on the same document simultaneously. Yeah, so it's same like the imagination or on the of the overview is like the how the Google Docs works today. Yeah, we can access in the same time, and then we can work with our own version. But the Google Doc can have capabilities to uh, what I say uh, to to see what your edits, and then we can track what the change and also etc. Yeah. So that will be the important point. Yeah. So because of when we see this one, actually the blockchain is contain specific information or databases. So it's mean when we see this architecture, uh, it's not only just it's not like the database architect centralized database uh, architectures. Yeah. When we take a look in here, is that when we have the traditional architecture, that we place a one main server that work as a web server and also the database server, and then all the access using the PC, laptop, and also smartphone will be accessed the server. Yeah, because all the data will be placed on the server. So in here, the server will keeps all the required information in one place. Yeah. Yeah, of course, the advantages is easy to very easy to update. Yeah. And then the server will be centralized database and will be controlled by a number of administrator with the permission. So And the PC, the laptop, that the smartphone that connect is only just access, yeah. Or maybe the administrator will be, will be accessed from the PC, smartphone, and also the laptop. Is they can also do that one, but using the permission or the right and the access right to the server. But in the other architecture that we call the P2P network, so it's mean all the computer will be have the opportunity as a node, and also they have a server. They also have the record of the transaction. Each participant within the network will be maintained, yeah, approve, and update the new entries of data or transaction. And the system is not controlled by individuals, yeah, but everyone within the block network will be control of the transaction, and each member will be ensured that all record and procedures are in order, which result in data validity and security. This party that do not necessarily trust each other are able to reach the common consensus. So in here, you can see that the common consensus is everyone will be, have the responsibility and participate on the maintain, approve, and update the new entries. Yeah, and also the node will be, will be keep the information in their own node. So it's mean the databases will be distributed to all the network, and we can access each others directly. Yeah, in here we can the different with this with the client server architectures. We trust all the data in one place, and then we let the administrator will be manage the security and also the access to the data on the database server. But in here, we doesn't need the administrators, yeah, because all the data and access will be owned by all the participants that involved in the network. So in here that if, for example, in the client server, if one parties want to change the record and then change the information in the databases, so if they ask the administrator and have the access, they can change. But unfortunately, the other participant will doesn't have any access or information to check the change, and we doesn't know what happened in the data. But in here, every change will be known by all the participants, and it will be very transparent, and also will be very easy for the P2P network to track what happened in the transaction. So that will be a difference. So in here, in one place, the security and also the data validity will be more high. Yeah. But I understand maybe our understanding now about the data security and validation, it should be in one place. Yeah. But in here we have new paradigm about the how we reach the high data validity and security using this blockchain architectures. Yeah. So that will be difference. So the key point of this one is all the participants in the blockchain will have the significant contribution to ensure that all the record and procedure are in order. Yeah. So I will discuss later about how it's working. But the most important thing is you can see that the difference is very significant on the approach of the networks. Yeah, and the architecture itself. Yeah, actually, and yeah, of course, based on this one, is the blockchain is decentralized, yeah, and then have a distributed ledger, even it's defined as public or private, of different kind of transaction arranged into a P2P network. This network consists of many computers, but in way that the data cannot be altered without the consensus of the whole network. The whole network, it's spirit computers, yeah. So that's mean you can see that will be very the different kind of the architecture, and then it will be very very tight and very very strict, yeah, on the on the validation, because if we alter the data, we change the data, but unfortunately, without the consensus or approved by the whole of the network, it will be not registered, will be not saved by the data, by the blockchain itself. Yeah. So that's why it's very important to have the consensus, because if we change in one item, it means we will inform to all the network that we change the one item, and then will be approved by the all the network, and then it will become the consensus, and then your transaction will be approved. Yeah, something like that. Yeah, so that will be the next one. And the structure of the blockchain technology is represented by a list of blocks with transaction in particular order. Yeah, this list can be stored as a flat file, or in the form of simple databases. Two vital data structure used in blockchains will be have a pointer and then linked list. Yeah, so you can see that this one, all the registered network will be list, and then will be stored in one of the flat file, and then all in the simple databases. And the list is consists of the pointers. Yeah, the pointer is the variable that keep information about the location of another variable. Yeah, so specifically this is pointing to the position of another variable. So this is the point. This is like giving the information or which the another variable that we want to connect it. Yeah. And then we also have the linked list, a sequence of blocks where each block has specific data and links to the following block with the help of a pointer. Yeah, so this is like the interesting one. Yeah, we have a pointer, and also we have a linked list. So this is the illustration about the data block that we try to explain to you. So actually, when we have a data block that is representing as record, yeah, in here we will start with the head. This is the head is the first data block that generate or developed by the blockchains. So because this is the first block, it will be consist only in the pointer. Yeah. So the pointer will be pointing and then give the address to access the second data block, and etc. Yeah, and then will be continue. So each block will be consist of data. Yeah, data will be the data itself. Yeah. So if we, for example, storing the data of the transaction, the financial transaction, so it means the content of the data will be the transaction itself. Yeah. And then we will have the pointer. The pointer will be give the information about the second data block, and so on. Yeah. So that's why the link between the block will be have a change. Yeah. So the green line, it will be the change. Yeah. So the nice one is because it is change. It's not. It is impossible if we have two chains, yeah, in one node. Yeah. So it's mean from the record number 2 will be also have a record number 3 in here. So it is very impossible because the pointer will be already defined only have one pointer, which is that will be have the information about the specific location about the another variable where the another variable is in the place. Yeah. So the next one is, yeah, of course, the blockchain, the chains on the data block will be n by the record number n if necessary, and then if there is no pointer, there's no pointer anymore, it will be null in here. So it's mean we will not have another change, yeah, another data block that will be added as a blockchain. Yeah, it's mean it's already complete. Yeah. So, but in the case the change of the block will be very a lot of the data block that will be accessed. Yeah. So in this case, I think it's very important to see that the databases uh, will be distributed on every block. Yeah. So that's very important things that you need to understand about it. Yeah. And in every data will be have some of the information or attribute in here. Yeah. So it will be consist of a block header, block header. Yeah. Uh, if we have number one block and then number two and number three, every block will be have a header, and then it also consists of hash of previous block header. So this is very important, very interesting, because they not store and keep their own hash, yeah, but the hash will be kept by the next the next block, yeah. So it's mean if you want to see or to access our own data in here, we need another blocks, yeah. So that's why the chain is very tight and also very strong in here. If we break the block, yeah, it's mean we cannot access anymore about the data. So that's make the the blockchain become very strong in the integrity, and also make secure, yeah, in other words. So yeah, this is like the unique of this one. So the chain itself, like I said before, is give the pointer to another record, and in the block itself, they already have the hash from the previous block. Yeah. So that will be very tough, yeah, to see this one. So if we want, if someone want to break the blockchains, so it's mean they need to hack all the chains that involved in the blockchains. Yeah. And this is like they also have the Merkle root. Yeah. This is like the Merkle root will be the information from the block transaction. Yeah. So it will be used for the block number one transaction and block number two transaction, and etc. Yeah. So it's like the architecture of the block and also the chains. Yeah. From this point, I think now you can see the characteristic of the blockchains actually basically is work with the computer network. Yeah. So in the P2P network, and also about the data block that as the transaction of the blockchain itself. Yeah. But in here, you can see the specific characteristic is they use the pointer, yeah, and also they use the linked list, and also they also have uh, the the structure on the block that using the previous hash, the previous block header for the hash of the current block. Yeah. So it's make unique and then make some integrity on it. Yeah. So why the blockchain become like that one? Oh, sorry, I will stop first. Yeah. Okay, we have a good question. I think in the chat we will discuss if block two has the block was one, which hash will then with the block number one hash. Yeah, good one. So thank you for the question, Ryan. So the logic is like this one actually. So it's mean the block number one there is no hash. Yeah. Actually, there is no hash. There's only initiation. They just like start button of start button for the reaction chain reaction. Yeah, so something like that. So if it says only execute the block is still empty, and then they only have maybe still zero. There is no transaction in there actually. Yeah. So they only have the block. There is no block. I think block header two just only block the empty block, and then they will have they run the block number one and etc. So same like this this logic, yeah, something like that. So okay, thank you. So if you have any question, please ask again. It's okay. Yeah, I will stop the explanation. And yes, thank you very much. So Yeah, the good one is what happened also if in the end of the block. Yeah, I think it's same. Yeah, we only have the previous from the header number 3, and then there is no transaction in there. Yeah, there is null in there. Yeah, so that will be how the chain work. Yeah. Yeah, actually, when we see this point, it is like the blockchain is like a chain reaction. Yeah, from the start button, and then the chain will be end by if the reaction is end also. Yeah, so that will be the next one. So based on this structure, actually, what the main advantages of the blockchains? Yeah, the first is cost reduction. This is we call the cost reduction because a lot of money is spent on sustaining centrally held databases. Yeah, by keeping data current secure from cybercrime and other corrupt intention. I think you also agree. Yeah, today we already have this issue. Yeah, in the AHAC application and also in the Peduli Lindungi application and so on. So we will try, you will invest a lot of money to secure your databases and also manage your databases, especially on your capacity, your storage, and also other things. But I think yes, I agree it's debatable too. Sometimes money is it doesn't as first first consideration. Yeah, but the most important of the blockchain, actually, I agree with the second point. Yeah, the story of data. Yeah, uh, within a block structure, it is possible to check the history of any transaction at any moment in time. Yeah, so that's very important. Yeah, because sometimes when we have the centralized databases, manipulation still there. Yeah, we can found the system is manipulated to reach some objective. Yeah, so some things. Yeah, to support some illegal transaction, for example. Sometimes it's also happen not only just because of that, yeah, because of the crime itself. Yeah, some parties want to intercept the system and then add some information in there and make the integrity of data is broken, and then we cannot trust anymore with the data in there. Yeah, so you can imagine like the issue on the in the in the health application. Yeah, today. Yeah, so what happened in the future if we not trust anymore with the application? Yeah, so because we already stored all our private data in there, and then unfortunately there is a guarantee that the data is secure. So in here that the blockchain have the opportunity and then give some possibility to yeah, to actually to check the history of any transaction. So if today uh, if we have some some change of the data, yeah, and the data came, we need to consider to take a look and analyze what happened in the past about the change of the data. So we need to know about it. So we log the data, and then we can see from the log, and then we also because in the blockchain is every changing will be have as a new transaction add to the change. Yeah, so this is a ever-growing archive, while a centralized database is more of a snapshot of information at a specific point. Yeah. So that the point, I think, and I like this word, the ever-growing archive. Yeah. So that would be very important. So I think we go to the chat first. I think we have some question from Bagaskara. Yeah, how about tumbling? Yeah, what you mean about tumbling? Can you explain what the main point of what your point about tumbling first?
If I may speak, sir. I watched a video on YouTube about like farms that use Bitcoin as a main of transaction, and it spoke about tumbling, like breaking down from one transaction to multiple transactions,
Mm,
like to the end account. So basically, making it like hard to trace.
yeah.
How about that, sir?
Okay. Okay, thank you for the discussion. Yeah, I agree with you. Tumbling, I think one of the case that still to to handle by the blockchains. Yeah, in this case, like I give you some case here in the blockchain fraud that we is also using the tumbling way. Yeah, they make like a double account on the Bitcoin mining and something, and then they intercept the the transaction to collect it the uh, the Bitcoin itself, yeah, and then they try to to flowing the transaction into the fake account. Yeah, say it's also happened in the blockchains today. Yeah, so yeah, I think it is very still possible to do the tumbling things. Yeah, but I think at least the log of the transaction or the list of the activity that some of the tumbling activities or another activities still on the record on the blockchain structure. So, but yeah, to handle or maybe to detect the tumbling, yeah, we can do on the blockchain. But yeah, I think I still agree that the tumblings still can happen in the blockchain, yeah, because it's already also happened now. Yeah, so I think that will be the nice one. Okay, thank you very much, yeah, Bakas, for the link. I think we'll be explain something about it. Yeah. Yes. Okay. Thank you very much. We will consider later. Yeah. We will continue. Yeah, but I think that will be also happen. So like when you see the blockchain, because they are more like to keep the data security and also the data validity using the very tough on the data history record and then ever growing archive and etc. I think the blockchain is useful for very specific or very specific business processes. Yeah, so I think that will be some discussion later. Yeah, and then the next is about the purpose is also for the data validity and security. Yeah, why it's very important? It's very important because once entered, the data is hard to tamper with due to the blockchain natures. Yeah. So why it's happened? Because you can see in here, if we have data that the new data that add to the block into the chains, if we cannot anymore to change this data in the record number one. If we change the data in the record number one, it become the data number will become the data in the record number two. If we alter the data, will become the data in the place on the record number three, and etc. So that would be the blockchain works. Yeah. So based on this one, the structure, it's mean we cannot edit and we cannot enter the data actually. Yeah. So because the nature is like that one. It's different with the databases. In the databases, if we have a table, if we have record in there, if we have value on the database, we can alter the value. Yeah. If we have the privilege on the databases, of course. So that's why the different architecture become differentiation in this case. Yeah. I'm not trying to to propose that the blockchain is more secure. Yeah, but from the nature of the structure, we can see that the security is different. Yeah, so it will takes time to proceed with record validation, since the process occur in its independent network rather than via compound processing powers. Yeah, that means that the system sacrifice performance speeds, but instead guarantees high data security and validity. Yeah, so that would be the point. So in years that the blockchain uh, I mean, the blockchain advantages is on the history of data and also the data validity and security in the frame of the blockchain nature, of course. Yeah. So that will be the point. So the question is like when I ask you to collect some information about the potentiality of the blockchain implementation and also unpotential blockchain implementation, you will we will try to identify more which one is more compliant with the blockchain nature. Yeah, after we discussed today. Yeah, because yeah, the nature will be like this one. Yeah, we have a record, and then we have a pointer, and we have a hash, and also the kind of the structure of the blockchain is very different. If, for example, we try to compare with the database architecture. Yeah, so that would be the differentiation. And we go through to the to another things. Yeah, so in the type of the node, we have uh, try to manage, yeah, all the node that in the in the blockchain node. We can arrange, yeah. For example, he become a validator node, or maybe he only become a member node. Yeah. So the validator node or the validator node is can put initiate and receive and validate transaction. So you can see in here, if we go back to the structure, the head and also the block zero header, for example, and the block, the initiation block is only will be placed on the validator node here, because they are the node that initiate, yeah, they initiate the transaction. Yeah. And then the member is only initiate and receive transaction. Yeah, so we can actually we can define this one, yeah, because yeah, I think you also understand, if we are in the same time joining the blockchain network, it is very, it will be in the question, who will be start the transaction. Yeah, who will be initiate from the first time the transaction. So it's mean one node will be the initiator. Yeah, after they initiate, the all the party will be validate, and then they will work as blockchain processes. Yeah, so in here, the member node is only just do the transaction, yeah, initiate and receive transaction, and they cannot do be the validator node. Yeah, so we can assign one or two or three or four validators for to help the validation of the processes. So it is very important, because if we let only one node as validator, it will be centralized. Yeah, it will be centralized in the decentralized node. Yeah, so it will be same, I think. Yeah, yeah, same with the member node, I think. So based on this type, actually we will have a several type of the architecture. Yeah, we will can have a private blockchain architecture. Yeah, is opposed to public blockchain architecture. Yeah, the private system is controlled only by user from a specific organization or authorized user who have an invitation for participation. So you cannot, you can join the network even you are in the outside of the organization, but only using the invitation. Yeah, it seems like, for example, I try to mining the Ethereum, yeah, for the Bitcoin. So I need to register first. Yeah, actually, when I do that one, do Ethereum mining, actually I become a private blockchain architecture, because I only work for them. Yeah? And another thing is consortium blockchain architecture. This blockchain structure can consist of few organizations. In a consortium, procedure are set up and controlled by the preliminary assigned users. Yeah, yeah. This is like, for example, the university blockchain network. Yeah, initiated by several university in the US, and then the other university join the consortium blockchain to achieve some purpose, and then we can register, and then we can join this network. Yeah, but unfortunately, the setup, the control is by the early organization that already initiate the consortium. So this is like the comparison between at least three type architecture of the blockchains. Yeah, the public blockchain, consortium blockchain, and also the private blockchains. Yeah. So the first properties that we can see for as differentiation is consensus determination. Yeah. In the public blockchain, all miners will be involved in the consensus. Yeah. But in the consortium blockchain, is selected set of nodes. Yeah. And the private blockchain is within one organization, only one organization that can do that one. So I mean, you can see in here the validators node will be applied in the air. Yeah. So it's mean in the public blockchain, all will become the member and also will become the validators. Yeah, because all miner will be arranged consensus. But in the consortium blockchains, not all the nodes get involved in the network, yeah, but only selected set of nodes, yeah, maybe in the early stage of the organization that join the consortium. And the private blockchain is all the nodes that inside the organization. The read permission is will become the public, yeah. In the consortium will be public or restricted, and also in the private is same, yeah, public or restricted, yeah. And this is the immutability level, almost impossible to tamper. Yeah? Yeah, this is the public blockchain because you already know that all the nodes will be have some privilege, yeah, have some characteristic, and the consortium will be could be tempered because yeah, you know, the limitation is because of the consensus itself, yeah, because if selected set of node, yeah, it's mean, you know, we can attack the node that's already selected, that we will have the authority to do something in there. And the efficiency use of resources, of course, the public blockchain will be low because we consider to all the node maybe is not in the same resource level. Yeah. So in the consortium and the private, maybe if you want to join, you need to comply or you have a same level with the other node that already exists. Yeah. And the centralization is in the public blockchain is there is no centralization. It become purely public, and there is no centralization. It will be decentralized in all the aspect. But in the consortium will be partial, yeah, will be partial centralization, and the private will be centralized. Yeah. So the physical network will be, you know, decentralized, but unfortunately the rule of the play will be centralized. Yeah, so I think that's will be something. Yeah, but it's okay if we agree with the consensus. Yeah, so that is the consensus processes. It will be permissionless. Yeah, so it's mean there is no, because all will become you know, the major parties. So I think there is no permission needed for this. Yeah. So in the consortium blockchain will be need the permission, and the private blockchain also have need permission. So that will be the architecture. Yeah, I think it's mostly like in the cloud. Yeah, we have a public cloud, we have also the you know, the private cloud, and also we have the consortium. Is like the hybrid cloud, I think. Yeah, something like that. So, and the next is the main component for the blockchain can be work. Yeah, we need to have a several component. Yeah? The first is node, of course. Yeah, this is the you can be user or computer within the blockchain architecture. It has an independent copy of the whole blockchain ledger. Yeah, so from my experience, for example, if I want to do some Bitcoin mining, yeah, for example, so I need to register and then I need to set up the blockchain architecture in my own, and then I need to copy, and then I need to replicate the share ledger that is already, you know, is already facilitated by the node, and then I can run the algorithm there. Yeah, and then transaction. This is like smallest building block of a blockchain system, consists of record and information that serve as the purpose of the blockchains. Yeah, so we need to have the transaction in that. And then we also have a block. This is like a data structure used for keeping a set of transaction, which is distributed to all nodes in the network. So after we have the transaction will be placed on the block. Yeah. And then we also have a chain. This is a sequence of blocks in specific order. Yeah, the specific order is like this this chain structure actually. Yeah, we using the hash, the previous hash, and etc. And then We also have the miners, specific node which perform the block verification process before adding anything to the blockchain structure. Yeah, so we need to this component miners. Yeah, so yeah, it is like the algorithm to get something, yeah, on the before we build the blockchain structure. And then we also have a consensus. This is the consensus protocol. It will be set of rule and arrangement to carry out blockchain operation. Yeah, so yeah, actually it's like algorithm and application. Yeah, so that's why like the Ethereum and then the what do you call it, the Bitcoin and other Bitcoin things. I think is also have the consensus, very unique consensus. Yeah, according to their works. Yeah. So this is the illustration how the blockchain works, yeah, in very high level, yeah. So when we have a transaction is requested by the node that involved in the blockchains, uh, then a block will be created to represent the transaction, yeah. So it's mean we will create the initiation of the block, yeah. And the block is sent to every node in the network first, yeah. So we announce that our node acts in the block, yeah, to do some transaction. So after a block is sent to every node in the network, the node will be verified. Okay, you can do that one. Yeah, so there will be the validation of the transaction in all the node. So it's mean the all the node will be know that you on the process to process something, yeah, in here. And then after that, the node receive a reward if the transaction is complete, and then you can generate all the transaction in the good way. The node will be receive a reward for the proof of work, yeah, and the block is added to the existing blockchains, yeah, and the transaction will be complete, yeah. So that's why actually when you do some Bitcoin things, actually your Bitcoin is reward for proof of work that you success to create a block in there, yeah. So that's why I think people still lost in the concept that we do something and then we have the Bitcoin, but actually the Bitcoin is like the reward that we achieve because of we add we already finish do some transaction to add the block, yeah. So that's why it's very important to see this one, yeah. So this is like a simple way how the blockchain work, yeah. So you can see that the block will be added in the existing blockchain, and then we will have a lot of blockchain change, and then the transaction will be finished, yeah. So this is the each block blockchain block will be consist of certain data, yeah. For example, your information of what your transaction and the hash of the block, yeah, and then the hash from the previous block, yeah. So that will be the important things. And the data stored inside each block depend on the type of blockchain, yeah. For example, in the Bitcoin blockchain structure, the block maintain data about the receiver, sender, and that amount of coin, yeah. So that will be the transaction. So it means the transaction is like generating the Bitcoin, yeah. So that will be. So what is the hash? Yeah, a hash is like fingerprint. Yeah? So it is like long record consisting of some digit and letters. Yeah, and each block hash is generated by cryptographic hash algorithm. Yeah, using SHA 256. Yeah. So this is like the algorithm to generate that one, and consequently, this help to identify each block in the blockchain structure easily. Yeah. And the moment a block is created, it is automatically attached a hash. Yeah. So it means every block will be attached by a hash. While any change made in a block affect the change of hash too. Yeah. So if you want to temper or want to change the block, of course, it's not only change the block, but also will be change the hash too. Yeah. Hash help to detect any change in the block. If there is any change and not necessary it will be identified as truth. Yeah. And the final element within the block is the hash from previous block. Yeah. This create a change of block and is the main element behind blockchain architecture security. Yeah. So yeah, block 45 point to block 46. Yeah. And every first block in chain is a bit special. All confirmed and validated block are derived from the Genesis block. Yeah. So that's the important things. So I think this is the very important slide for you, yeah, to understand about the heart of the blockchains. Yeah, it's not only just arrange the network between the node that involved in the blockchains, yeah, but the important thing is the play of the cryptographic hash algorithm that really have a very important point in here to generate a hash, and then the hash will be used to identify each block, and also the hash is it will be very important to identify if any change happen in the block. Yeah. So yeah, this is the very important thing. And then the hash is also will be used for from previous block and then used for the block itself, and then it will be used to validate the block itself. Yeah. Yeah. So that will be the challenge also for us, yeah, to see how we can work for the blockchains. Yeah. So you can see in here one of the open challenge for you, yeah, actually, and also the research that we can do in the future is how we can uh, we can set or we can develop the new algorithm, yeah, to have the SHA 256, yeah, to have the new the more the most the most the most secure hash algorithms, yeah, because if we only uh, we only just let the hash algorithm in the pure way work, even it's secure, yeah, because it's already using the 256 hash configuration, but I think still we have challenge to have the, the the very strong algorithm for it, because in the especially in the security issue, we we will still face the challenge about the security issue because of the using of the hash, that the hash can be cracked by other parties, yeah, because they also know about the configuration of the algorithm and how they can deal with the algorithm actually. Yeah, so that also one of the the point, yeah. So that's why in when we see many many discussion about the blockchain, a lot of still consider and also have a lot of discussion, more discussion in the in the hash algorithm itself. Yeah, so I think that's just no problem, that's good enough, because yeah, we have this point. Yeah. Yeah, so it doesn't matter about actually, yeah, about it. Yeah, so uh, let's see about it, and then we will discuss later next week about the hash, yeah, because it will be very interesting to see about it. Yeah. Okay, and then we go to next. And how about if the block have any corrupt attempts, yeah, to provoke the block to have a change on it? All the following block then carry incorrect information and random the whole blockchain system is invalid. Yeah, it's simple as that. Yeah. So if we have some consequences about it, and then we have some some difference information about the hash especially, so it's mean the whole system will be say that it's invalid. Yeah. In the worst case, the node that involved in the blockchain node will be considered as invalid node. Yeah, it means that you will not capable anymore to join the blockchains. Yeah, in other hand, in theory, it could be possible to adjust all the block with the help of strong computer processor. Yeah, because we will change around the world. Yeah. However, there is a solution that eliminates this possibility called proof of work. Yeah. So in here, in the blockchain, we have another component that we call proof of work. This allows user to slow down the processes of creation of new blocks. Yeah, it's take around about 10 minutes to determine the necessary proof of work and add a new block to the chain. And this work is done by miner, especially node with the Bitcoin blockchain structure. Miner get to keep the transaction fee from the block that they verified as a reward. Yeah, so that would be a proof of work. Yeah. And this very interesting things, yeah. Each new user joining to the peer-to-peer network of blockchain to achieve full copy of the system. And you can see this one that full system will be placed to the node that involved. Yeah. And once a new block is created, it is sent to each node within the blockchain system. Yeah. And then each node verifies the block and check whether the information state that is correct. If everything is all right, the block is added to the local blockchain in each node. Yeah, yeah, this is like how the blockchain will be work. Yeah, so you can see that all the nodes have same capabilities to see this one. And all the nodes inside a blockchain architecture create a consensus protocol. A consensus system is set of network rule, and if everyone abides by them, they become self-enforced inside the blockchains. Yeah, so that would be also the characteristic. Yeah, yeah. So in here we can see that uh, every user will be have the system also, and will be have a consensus of protocol. So when we develop a private blockchain, yeah, will be a decentralized blockchain application. It's designed just the same as any other normal software product. Yeah. So functional specification, UX, UI design, and architecture plan are required for its development. It's crucial to identify the app functionality, user role, and think over the system flow and the interaction between user and information. Yeah. Uh, yeah, of course, this is like a blockchain network will be a very, very depend on the infrastructure, yeah, within a particular environment, yeah, inside one of your organization. So if you think to develop your own application to implement the blockchain structure, yeah, so we need to take a look about the infrastructure itself, yeah. And then the blockchain code, yeah, refer to the tasks and goal this blockchain solution has been developed to perform, yeah. And of course, there are few open source solutions used to build a private blockchain architecture. Yeah, this popular among them is Hyperledger by Linux Foundation. And this is also widely used by IBM and also another organization. And Hyperledger Composer provide a set of tools for creating blockchain architecture. So if you have time, you can see this one, Hyperledger. Yeah, this is like the open source blockchain technologies. So let's see, take a while to see the Hyperledger. Sorry, it's long for me. Okay, I will wait. Yeah. Okay, so that we can use the Hyperledger things to do that one. Yeah. So this is like the example how the blockchain can be developed by several technology that exists today. Yeah. So this is like we can using the blockchain network creation in here. Yeah. So we see we have several roles or consensus in here. This is the first is asset participant transaction. Yeah, we can use the model file in here using .cto, for example, or other things. And then we can also using the transaction function. We can develop in the script file using the JavaScript or something, yeah, GS. And then we can add some access control using the ACL things. Yeah, we apply some access control rules, and also we can implement the query definition using the query file. Yeah. So in here, we can use a composer to create a business network definition. Yeah, that we have a model, script, and also query files. Yeah. If we have this all the component, we can package all this definition into the business network archive that it can be ready to deploy it somewhere. Yeah, and then we can use the Hyperledger fabrics. Yeah, that we can install using the cloud system or maybe in the local system, and then we can access to through to the web browser or using the Node.js something. Yeah. So I think the Hyperledger give some, uh, some opportunity to have all these things here, and then create your own blockchains. Yeah. So this is like the good one, I think. Yeah. So if you want to learn, I think you can learn a lot of things in here. Yeah. Actually, currently I looking for the student that maybe for your thesis or maybe your seminar or proposal to using the Hyperledger to our environment. Yeah. So the use still defined, but hopefully we can use the Hyperledger for something that we can use at least in the campus. Yeah. So you can see this one. This is a lot of various blockchain technology, yeah, that already developed by the community, and all is open that we can use, and then we can download all the things here. So hopefully in the future we can see our own tools or maybe implementation to in this community. Yeah. So that's the Hyperledger. You can learn later. Yeah. So this is like you can see what the inside the blockchain network creation. Yeah, it's very important to see the architecture of the blockchain application itself. Yeah. So so if you have interest to take as your thesis, for example, I think you can use this one. Yeah. Of course, to to create the code, yeah, behind the blockchain, we need to have some point that we need to consider. Yeah. So after the blockchain network is set up, the next step is to agree upon the type of business transaction happening inside the blockchain architecture. Yeah. There is a role in legal agreement, and logically with the blockchain code, this refer to smart contract are called by chain code or business network definition from Hyperledger Composer. So we can like we create some of the business model, yeah, or some arrangement on here. In the real world, the blockchain contract has participant, asset, and transaction. For each transaction, a transactional processor function is written. Yeah, so it is like using the JavaScript and layout things that will happen once the transaction has been generated. Yeah, so that will be the creation. Of course, to develop this one and to support the blockchain things, you need to be considered to enhance your capabilities. Yeah, because still require a lot of technical skill and complex background. Yeah, so especially this one, blockchain architecture is still very limited person in here. We need a strong background in computer science and engineering. We need to know the person that understand about the consensus method, data structure, and decentralized ledger, and also the cryptographies and cryptocurrencies. And data security is also highly sought after. And recently, the task of developing a blockchain has been simplified with the help of Ethereum and other similar blockchain software. Ethereum is not only the Bitcoin things, but they become blockchain technology. Allowing for the building and deployment of decentralized application using that structure, using the architecture. So I think when you see this one, Ethereum, this is like become not only just Bitcoin application, but also become a platform, I think now. So I think you can see that one using the application in here. That's also a very interesting point, that the development of the Ethereums. And then in the term of coding skill that require for blockchains solution, you need to have capability on the C++, Python, Java, Ruby, and also web development skill, I think. So you can consider this one. So based on this, I think the architecture of blockchain have some unique key characteristic. The first is cryptography is validated and trustworthy during the complex computation and cryptographic proof of among involved parties. And then you also have the immutability. Any record made in a blockchain cannot be changed or deleted. And then we also have the provenance, refer to the fact that it's possible to track the origin of every transaction. We also have the centralization. Each member of the blockchain structure has access to the whole distributed databases, as opposed to the central-based system. Consensus algorithm allow for control of the network. And then we also have the anonymity. The network participant has generated address, not user identity. This keep user anonymous, especially in public blockchain structure. It's also different if we go to the private or the consortium one. And transparency, the blockchain system cannot be corrupted. This is very unlikely to happen, as it requires huge computing power to override the blockchain network completely. But we still consider that maybe China or maybe United States have these capabilities. This is like the of course it will be hard. If we see in the architecture, it will have the to have some industries possible to complete transaction much more quickly and with trust. With trust, especially with trust. And then cost reduction for business or cross enterprise processes while removing intermediaries, inefficiencies, and duplication. And also introduction of modern digital interaction, opportunity to keep detailed control over business processes and transactions without a central control point, and of course removes cheating, cyber attack, and other electronic crimes. So that will be the nice one. This is the reference that I use, and this is the use case. If you want to see what kind of the contract or consensus that we can build in the blockchain, for example, this one is the very flowing consensus or transaction that we can support by the blockchain. We have like from the farm, from the plant, from the shipper, customer, we do some supply something. We have a mine, and then we have a retail bank, we have central bank, and they connected all the process from the beginning until the end of the processes. So that will be the use of the blockchains. So back again, I think I want to open the link that already shared by Bagas. Let's see for a while, and then discuss in a few minutes to see what the issue. I think that's good enough, because it's also discussed about the the blockchain issue, especially security issue. You can also access to on your network, because I think my network is not very good. This is about the dark web. I agree with you. This is also the issue of the in the blockchain. I think even the blockchain have some capabilities on the immutability, on the some of the advanced features that they can have, but I think I agree that they cannot also avoiding this kind of the issue. Yeah. So I think that will be our consideration for the next year. So yeah, it's secure, but not 100% secure, I think. But it also have some challenge, yeah, to see the blockchain as a very secure way. Yeah? So that will be our also our consideration. Okay, thank you, Bakas, for this raising this issue. I think that's good enough because I think we will discuss this is more detail, yeah, in the very specific discussion later about it, yeah, especially on the challenge of the blockchains, yeah. So avoiding the threat and also handling the issue in the blockchain in the futures, yeah. We will use this one for another discussion, yeah. Okay, for the next is I think I will suggest you to try to learn more about this technology that I want you to see the hyperledger, yeah, first, yeah. So for the next week, I would like you to see to learn about it, and then uh, find one of the project in the hyperledgers. Yeah, for example, this one, they have a lot of the hyperledger project, yeah, in here, and then try to learn about the hyperledger things, and then I would like you to make some report to me, in the presentation is okay, in the one of the small report is also okay. I want to you to compare about the hyperledger and then like Ethereum, yeah. So make your some of the some benchmark, and also some what your insight when you see this one about the Ethereum and also about the hyperledger technologies, and especially in the point of view when we want to develop our own blockchain application, yeah, yeah, because my direction is also how to introduce you to develop our own blockchain application, yeah. So hopefully we can learn a lot about it. So you can freely discuss and also identify and benchmark the Ethereum and also the Hyperledger based on your own version, and then I would like to let you to present to me in the next week, yeah. Yeah, so you can find a lot of things. Any question about it, about the assignment and also the things that we already discussed today?
Sir, so our task for the next week is to build the report comparison of Ethereum and Hyperledger, sir.
I think the comparison is you can found by your own and also your friend point of view. Yeah. So I would like you to make some free comparison. Yeah. It's up to you. You can, if you found some interesting things about Hyperledger on the architecture, for example, you can compare it, or maybe you can actually Ethereum is also using the Hyperledger, for example. It's also the comparison things, I think, that you can show them. Or if difficult to find more deep about the technology, you can compare also the application side. For example, the Hyperledger is mostly close with several application that they already released, or maybe in the Ethereum it will be close with the application that maybe we can see from the website about the showcase and so on. So I think that you can also make that one. And if you want to compare in very point of view, is good enough. If not, yeah, just pick one point of view, yeah, especially in the architecture or in the application, or maybe in what kind of comparison. Okay, so I think that will be a free comparison for you.
Okay, sir. Thank you very much.
Okay.
Okay. Okay, that's Ruby. So I think, yeah, Ethereum is one of the good things because they also have. I think the Ethereum is, from my opinion, yeah, my first opinion is they already have the application. They also, and then they develop some platform to develop some application using their Ethereum blockchain structure, and also they have some information how we can build all the application using the Ethereum technologies. Yeah. So hopefully, based on this, you can you can learn about this is how we can work with our blockchains blockchains environment. Yeah. So hopefully, if the condition is on the plan, we can access the lab and so on. I will set some of the maybe one of the server to help to show you about the how we can work with our own environment, and then we can generate our own blockchains environment. Yeah. So and then you can access freely from your home and etc. Okay. Okay, that's it. I think we will. I will wait for you to learn about the Ethereum and also the Hyperledger and make using your previous group. I think that's okay. And then like next week, bring your presentation, and then we will discuss more deeply about it. Yeah, because next week our discussion is about the blockchain processes. Yeah, especially to see how we build the algorithm, and then we using the hash, and then how we build the application on top of the blockchains environment. Okay, for today, I think that's it from me. Thank you very much for joining the session. Any question? Any question from you?